Okay, QuickTime's going. All right, now today we'll start a new topic, and so this is it on like double angle, half angle. Notice that I went back in your homework and gave you sum and difference identities also, even though you had those type of questions on your last test. Just to reemphasize that there's the sum and difference identities, that from those we derive the double angle identities. From those we derive the half angle identities. If you have a double angle identity, you obviously also have a half angle identity sitting in front of your face. If two A's over here and A's over here, you've got double and half, whichever way you want to put it in. Some of you I don't know. Some of you may have just decided to go, I'm just going to learn the formulas that I barely introduced in the last class with the big square roots on them. But you saw me work one. It's really not less work. So I'm a proponent of knowing the double angle identities and doing the algebra from it. But you can do what you want to. We'll talk about different, maybe faster ways to get some things done if you feel like some of your homework got a little bit long and involved. There was another thing I was going to say. Oh, what was it? I don't remember. Maybe it'll come to me in a minute.
Is there ever an instance where you can only use the half angle, like you won't be able to use double angle?
No, because that's where they came from.
Right. Okay.
Okay, that's exactly where they came from. I did it really fast, but in the last class I started with like cosine 2a equals maybe 1 minus 2 sine squared a. And this is half of this.
Right.
So all they did was rearrange it and write those little square root formulas in the book. Can you see here? I'd have to do a little addition and subtraction, then some division, then square root plus or minus.
Mm-hmm.
That's exactly where they got it from. So you're doing it one way or the other. Okay. Did I answer your question?
Mm-hmm.
Is that what you're asking? Okay. And again, I use these double angle identities exclusively in calculus when it occurs. It's my students in AP Cal BC are entering a place right now. I had one in class yesterday where we had sine squared or cosine squared, and they can't deal with it. Like nobody can. And they have to change it into, they have to get out of the squared. So if they're trying to, what we call integrate that one, okay, an integral looks like that. You see it like in the background of really smart people, advertisements on television or something, you know, or behind Einstein, okay? Anyway, when you're trying to do this, you can't. You can't unpack that. And so they have to rearrange it. And do you see if they rearrange it and change it into some form with a cosine 2a, they don't have a squared anymore, which I know you don't have any idea why that's important right now, but just take my word for it, it's important. I'll have to rearrange that. Then I can solve the problem only after I rearrange it. Also, we're at just a tiny point right now where Mr. Hill and I emphasize different things in this particular section. I really hit hard on the algebraic manipulation of the double angle identities. The goal of this chapter for both of us is that you know the sum and difference in double angle identities, but then you notice it goes into the hundreds of problems, right? A lot of those problems are the technicalities of you manipulating things algebraically so that you're ready for calculus. Because once you do the first step in a calculus problem, you know, all the teachers in here who taught calculus, they would say that once you've done that first step, you might walk into a room and see me going like this. If you see me teaching calculus or one of the other teachers, all of this works algebra. And it can last for a long time. It's really kind of fun. You know, we're all good at algebra. But, so anyway, having said that, Mr. Hill goes more into the multiple, like, power reducing formulas. I never need those in calculus. I don't remember a time that I've ever needed it. If you're an engineer and you need it, you look up the formula and you would do the algebra. So just know that I'm taxing your algebra in the same fashion, just in a little bit different way. I just want you to panic if you looked at something someone had on their paper in the other honors class. I promise you I'm not going to let anything as the AP Calculus BC teacher creep by that you should know. It'll be the other thing. I'll make sure that you know more than you need to know, okay? So if the standards here my standards up here. The AP Calculus standards up there, which is really good. So I just want to end this section alone. All the other stuff will be the same. But, that's been a little bit during the year. There's certain teachers that choose certain things, but you're not going to come out at all behind, okay? So, anyway, I guess a case in point is our bicycle problem. Like they didn't have to deal with all those different gears, but they had to deal with something else. I can't remember what it was on that test. But whatever topic he labored on about, and we labored on about the bicycle problem, it was very intense, and I was very proud of you. So that kind of thing. Okay, so moving on. One thing that you ran into, and I didn't realize it until Lauren had come in, which was, I thought, well, goodness, why has no one else asked me this so far? When you ran into, I think, 112 or some number 106 or something was 112 degrees at 30 minutes is what that means. It's really weird looking because they unfortunately use feet and inches in mathematics for minutes and seconds. And the funny thing is you've really seen that more in your life than anything else probably that we're doing. Because some of you even have it on like your Vineyard Vines or your whatever shirt, like the latitude, the coordinates. And when we're typing things into our phone, like if we want to find a store over on the west side, it's actually using GPS. It's using coordinates in degrees, minutes, and seconds. When you were, younger and you looked at latitude and longitude on a map, you may have seen degrees, minutes, and seconds. If you buy a parcel of land, like when I used to own a house when I lived in the suburbs of Memphis, well, really I lived in the city, but that's beside the point. You actually have a document that tells you what your land is. Like if my lot was shaped that way and my house was on the lot, these actually are all given, they give you this so that you know where your property line, my neighbor Ryan lived over here, and Melissa and Mark lived over here. Well, Melissa and Mark wanted to maybe add on to their house. The people that bought the house after me built a pool. Wish I'd done that. But anyway, you've got to know where your property lines are. And they give it not just to the nearest degree, they give it to the nearest degree, minute, and second, which can also be converted to decimal, which I'm teaching next class. I've just tried up until now to be really careful not to let those problems creep in because the book has already addressed it, I just haven't. And the other class may never do it. That's another thing that's a little bit different, okay? But anyway, I think it's pretty important to see it just because it's very real world. If we pulled up some Google images, some property lines like real estate, you'd see degrees, minutes, and seconds. So I'm going to talk about that in the next class. But anyway, this is really trying to tell you you're halfway between 112 and 113. So if you got my email or maybe you looked up what that meant or you went to some conversion, hopefully you managed that. It was 112.5, okay? And you'll know more about it after next class. Okay, now that's all I really wanted to say about the homework, so now I'll take questions before we move on. What page am I on?
397.
Okay. All right. I want to say this also. This book is great. You're mature enough now and advanced enough to actually look at the examples and look things up, which you need to do for college or in a fast-moving AP course anyway. The book is great. Like, I don't like the Algebra 2 book. I don't think any of us ever use it, So, in fact, there's a bunch sitting there, right? But our book is great, and our calculus books are really good. So, anyway, moving on. Question, Elena?
So I just have like a question on how you get from, say it's root 1 minus cosine whatever over 2, and then you get it to be a root of something minus a root over 2. But
You can't get rid of the root on the inside? Is that bothering you, or you mean just...
like the say the cosine of the angle is like 7 pi over 4, and then you get rid of the 4 but somehow keep the 2 at the bottom.
Can you give me a specific problem to work where it comes up?
Sine pi, or 7 pi over 8.
All right, what number is that?
107.
All right, 107. All right, so 107, I'm supposed to find the sine, the cosine, and the tangent of 7 pi over 8. Okay, so I know 7 pi over 8 is half of 7 pi over 4, okay? And so, and by the way, the pi over 12s are 15 degrees if you convert it, but also doesn't that make sense? It's half of pi over 6. So the pi over 8 angles, they're reference angles. By the way, pi over 12s are either 15 degrees or 75 degrees, depending on where they are. Let me pause and talk about that. Pi over 12 is 15 degrees, okay? 2 pi over 12, wouldn't that just be pi over 6? Is 30 degrees, okay? What am I on now? 1 pi over 12, 2 pi over 12. What's 3 pi over 12?
45.
It's working out pretty good, right? What's the next 15 degree increment is 60. And so what was that? 3 pi over 12, 4 pi over 12. Okay, is working out with what you know. The next one is 75 degrees, but I'm on 5 pi over 12. And 5 pi over 12, isn't that right next to 6 pi over 12? Okay, so do you see how one of them's here, 5 pi over 12, and 1 pi over 12 is right there. You don't have to know all of that. I just wanted to make sense of it, okay? So the pi over 8s are 22.5 degree increments because they're half the pi over 4s, just so you know, all right? Just to make it real. All right, but anyway, what I'm going to do is I'm going to go cosine of 2 times 7 pi over 8 is equal to 1 minus 2 sine squared of 7 pi over 8. I can find the left-hand side. This is the cosine of 7 pi over 4 is equal to 1 minus 2 sine squared of 7 pi over 8. Cosine of 7 pi over 4 is root 2 over 2. Because it's in the fourth quadrant where cosine's positive. All right, so I'm going to move this over here.
So, yeah.
And this is 1 minus root 2 over 2,
Yeah.
which is 2 minus root 2 over 2. Getting a common denominator? So I divided, and I haven't divided by 2 yet. So I have sine squared 7 pi over 8 gives me 2 minus root 2 over 4 when I divide by this 2. Okay, and then I square root, and I'm thinking plus or minus. 7 pi over 8 is in the second quadrant. How do I know that? Because I'm thinking of 8 pi over 8, like I always do. Okay, so its sign is positive, so I get 2 minus root 2 over 2.
Right. So I was doing it where like I kept cosine sine pi over 4 as cosine sine pi over 4.
Wait, say it again.
So I kept cosine 7 pi over 4 as cosine 7 pi over 4 instead of putting it as root 2 over 2. And then I solved it from there. So then there was like 1 minus cosine 7.
Oh yeah, you're supposed to solve it numerically.
Right.
So
No.
did that answer your question? Or no?
I ended up solving, I got root 2 minus root 2 over 2, but I just did it algebraically instead of replacing.
Oh, you didn't put it in here? Did you
Yeah.
put it in at the end?
Yeah.
Okay. Are you okay with that, or do you want to?
No, because now I'll just do it like this.
That makes more sense.
Yeah.
Okay. You could do it at the end, but then you've got a complex fraction.
Yeah,
It gets a
and
little
then that's
tougher.
why- yeah, that's why.
And if you use a formula, that also happens.
Yeah.
So I would say don't do that.
Yeah.
Do it as you go. Okay. All right, girls. Other questions? Other questions? No? Okay, verify the identities okay, using one of the ones where you were supposed to verify the identities, use the sum and difference identities, and then fill in what you know. All right, Isabel?
Can you just do one of the verifying identities?
Yeah, do you have a certain one?
83.
Yeah.
All right, this is 83. 83 is this cosine, I'm sorry, 83 is a cotangent?
Cotangent.
Yeah, probably wouldn't have given you that one if I'd noticed that. Cotangent, because I didn't make you learn the sum and difference identities for cotangent. Cotangent of pi over 2 minus x equals 10x. Girls, if you're not needing to see what I'm doing, just try to maybe entertain yourself instead of other people so that I'm not talking over you. Or so your friends can hear. Also, I might say something you didn't think of, possibly. Cotangent, if I don't want to go and look up the identity for tangent and flip it over, like I know the identity for tangent, but I didn't make you know it. I know it's tangent A minus tangent B over 1 minus, no, 1 plus, wait, it's tangent A plus tangent B over 1 plus tangent squared, wait.
One minus. I think it's plus on the top. Minus.
Oh, it's I'm mixing it with the double angle. So it's tangent A minus tangent B over 1 plus tangent A tangent B. Then you would flip that over for cotangent. But you also could do this. You could do cosine of pi over 2 minus x over sine of pi over 2 minus x. That's maybe what I would do. So let's see what happens. I get cosine of pi over 2, cosine A, cosine B, plus sine A, sine B. Memo quizzes are supposed to make sure you know those really well. Sine of A minus B goes sine of the first one, cosine of the second one, sine A, cosine B, minus cosine A, sine B. All right, cosine of pi over 2 is 0, so it knocks this out. Sine of pi over 2 is 1, so I have sine on the top. On the bottom, the sine of pi over 2 is 1, so I have cosine on the bottom, because cosine of pi over 2 is 0 and knocks that out. And so I have tangent.
What? Wait, are you allowed to just, in the first part, just cross out the pi minus 2 minus x, pi over 2 minus x? It's simple.
No.
Yeah, because isn't it just 90 minus x is equal to sine over cosine?
Wait, hang on just a minute. Let me go. Nicole, what'd you ask?
Could you just, when you have the cosine pi over 2 minus x over the sine pi over 2 minus x, could you just cross out the pi over 2 minus x?
No, that would be like saying I have the square root of 3 over 3 factorial, and you're going to cancel out the 3's. Sine and cosine are math symbols.
No, not the could you, but
Like
they have
before
the, they
like,
have the same,
Okay, wait. Maybe I'm not understanding you.
like it's, well, if you had like,
You're not wanting to cancel this out, are you?
oh, I can't do that?
No, that's what I'm saying. These are, like, if I have 30 and 30, it's way different. I put the sine of 30 over the tangent. I have no business canceling those out. Then I just have, if I have this, I can't cancel out those 3's, then I would have the square root of what? Like, this means absolutely nothing, Nicole. If I said, get out your calculator and find the sine. Sine and cosine are math symbols, just like addition. It'd be like this. 5 plus 3 over 7 minus 3, and trying to cancel out those 3's.
Well, I didn't know it was like that because it's like multiplication, not.
It's not multiplication, it's of. Like, for instance, I have the square root of 9, or I have the sine of 9, or I have 9 factorial, or I have 9 squared. These are all math symbols.
Yeah.
This is not multiplication. That's the cosine of what? Cosine of pi over 4, cosine of pi over 2. It gives you a number. Those are not multiplied. That's a math function just like this. You're waiting to insert the right thing into it. And you get an answer. Does that make sense?
Yeah.
It's a math symbol. Okay? Y'all, Nicole brings up a great question about what you're able to cancel and what you're able to not cancel. And some of the calculus teachers are still fighting what you're able to cancel and what you're able to not cancel. Like, for instance, look at this. I cannot cancel x squared. Some of you would, you cannot. Okay? That's not an x squared. I know that sounds a little bit silly, but I'm being very genuine here. Please listen. If I have 3 plus 4 over 3, should I cancel those 3's? No, I would say the top's not a 3. It's on its way to being a 7. It's not a 3. It's not even a multiple of 3. I mean, I guess it could be depending on what you add it to, but you just have no idea. And another reason you can't cancel it, girls, is this is a common denominator. It's not fair just to do that. Y squared be going, what about me? Wasn't it supposed to also be divided by x squared? All right. Those plus and minus signs are like super glue. The only thing you can cancel with x squared plus y squared is x squared plus y squared. It's got to be the exact same number. If you have a plus or a minus, you're on your way to still finding something out. Okay? All right, tons of hands were in the air, so I may not have answered. Maybe you were going to clarify Nicole's question or ask another one. Okay, I'll start in the back. Brianna?
Well, it's on our memo page that like cosine of 90 minus x is sine of x, and that sine of 90 minus x.
You could have just done that. Yeah.
That's what I was-
Yeah. I'd love for you to know that identity. If you go into calculus or graphing knowing that identity, that it didn't take me but a step or two to find it out. But I'm so glad that I was kind of hoping a bunch of y'all were going to say that. If you are told to graph that or take the derivative of that or take the integral of that one day, Brianna's going to be well served just to go, oh, it's just tangent, so I know what to do. You could stop and find it, but that's way better. Yeah. And you're welcome to use that.
Could you like flip, could you put it over 1 and make it tan and use the sum and difference identities? 'Cause that's
Yeah,
what
if
I-
you know the tangent, sum, and difference. Yeah, that's what I started out with, but in a little bit different way. I was saying, while I was faltering through the identity, what I was trying to say, which I probably lost people a lot, couldn't quote the identity. I know tangent A minus tangent B over 1 plus tangent A times tangent B. But if I was doing cotangent, I would just flip that over. I wouldn't make it 1 over. I would just,
Yeah.
yeah.
Okay.
So same thing. Okay? You okay? Can't cancel those. Okay?
I'm just confused because if it's in parentheses, I always do.
Okay,
Well, it's like 1.5.
but cosine's not a number.
Yeah, I know.
Okay? Cosine's a math symbol.
I think where I always get mixed up when canceling is like when it's like something plus something, I have to remember that you can't cancel when it's a plus, but if it's like a time.
You
it's a little
can,
bit-
and that's where she was,
No,
yeah.
I know you can't do it with the plus. I just like whenever I see something and then just like 2 parentheses, I just think it's
No, I do
multiplication.
too.
Okay, so do you see that's not this? I am not multiplying cosine times 45 degrees.
Yeah.
That is not multiplication. So if I have this, I cannot cancel those. That's not multiplication. And it's not your fault. It's the people's fault that decided to use words instead of math symbols. You wouldn't do that if they'd made up a math symbol for it. It's when words start being used as math symbols, because this cosine makes me do something just like division or factorial does. Cosine's a math symbol. It's an operation, okay? But it's a word, so then it's like, what are these doing in here? Like logarithm, sine, and cosine and tangent aren't harder. But when people go, oh, you're a math teacher? I couldn't do that sine and logarithm stuff. Sine is not hard, is it? Doesn't it just mean go opposite divided by hypotenuse? I mean, how easy is that? But it's a direction. It's just that I think it's a word, and people are like, why are there words in here? So anyway, whatever that's worth. Nicole, I so wish a long time ago they had just made up symbols for sine, cosine, and tangent. I mean, gosh, if I can use this, why can't I use some other things? But they didn't. Thank you so much for asking that too, because I got stopped and started so much on my algebra and pre-cal and calculus of trying to do things I couldn't do that I had to stop and make sense of a lot of things. And I was really good at algebra. There's just all of these little picky things that come up that take clarification. So don't ever hesitate to ask those, because your friends are probably doing it too. Okay, anything else on homework? Okay, all right. Okay. Please always be checking and check it on Slater, however you can do it. All right, so new material. So actually, my first couple of months in New York, I've been here a few weeks. In fact, I got an email down in Memphis from Miss Edmonds, who used to sit right there, who I was coming to do her maternity leave. Like, oh, when you move to New York, like the math department is going to go to the Flatiron and do some sort of activity on Pi Day. No, it wasn't Pi Day, because I'd only been here a few weeks. It was in the winter. What was it? 5, 12, 13. Yeah, so it was one of the special triangles days. So, wait, was it March?
No, it was December. It was the 5th of December.
Oh, okay. So 5, 12. Okay, so I moved November 22nd. So that makes, thank you, Miss O'D. She knows what it was. I didn't know what I was doing. I was just following people. And they took me to Italy, so that was a thing. And then I saw the Flatiron. But what we did was some of the students also came with us or met us there. And the Flatiron is a triangular building. Like, everybody's seen it and familiar with it. But actually, if you look at it from overhead, it's a triangle. And so they gave everybody that showed up glow sticks. And we got and made like a 5, 12, 13 triangle or something. Anyway, it was kind of cool. But I just needed something for triangles today. All right, so what is the area of a triangle? Raise your hand, don't just call it out. Area of a triangle, raise your hand. All right, Danielle.
1/2 base times height.
All right, does anybody know another one? 2, okay. Girls, and you need to run back in here, Willie, because this is so incredibly important. There are 3 formulas for the area of a triangle. And you are sitting here, some people in pre-cal are seniors. You're juniors, okay? And you're just now learning this. And again, it's not your fault, but I'm trying to talk real adamantly like I do sometimes, like, please walk out of my room knowing this. I actually remind my AP Calculus students of it over and over again. Because there are 3 formulas, Mary and Grace. There's 3 formulas for the area of a triangle. 1/2 base time height is the most pitiful excuse for the area of a triangle that I know. Because it demands that I have a right triangle or that I go through some convoluted thing to find an altitude. Okay? Bella, do you know another one?
Sort of ish. I know that there's one for equilateral triangles with like a root 3.
3 side squared. A square root of 3 over 4 side squared. Yeah, thank you. But that demands equilateral. Right? So far we have equilateral, we have right triangles. And I have a story to make this really real to you in just a minute. Is that?
There's one where you use like sine and some other things, but there's like you use like the 2 sides and like the inner.
Yeah, very good. How do we know? ACT?
Yeah, but I don't remember the equation.
I'll give them to you. They'll be on your memo page. Very good. Okay, so you ran into it somewhere. Your thought should have been, as your ACT tutor is telling you, or program or book or whatever, you're looking at like, why do I do this? Okay? So, here's a true story. Have I told you my triangle plot of land story before? Okay. So stop me if I start telling it to you in calculus or later in the year. Go. We heard this stupid story. Okay. So it's not really stupid. It's very real. When my son Clayton was really little, I signed up and got somebody to cover my classes and thought, well, I'll be a mom today and I will go chaperone this little trip to go see the trains down at the state capitol. So there was a Christmas train going around a Christmas tree, and they have that around here too, apparently, where I can go to the botanical gardens and see a train. But anyway, so I'm like, oh, I'll sign up and chaperone because I never did that kind of stuff very much, right, Lily? So I was there in my mom capacity, and I knew a couple of the moms, but some of them I had not met yet in his 3rd grade class or wherever old he was. So I'm leaning against the wall at the state capitol, just making sure all the kids are where they're supposed to be, I guess. And this other woman standing next to me, and she goes, hey, I'm whatever, I forgot her name. And she's like, what is your job? What do you do for a living? And I'm like, well, I teach at the high school. It was a K through 12 school. I'm like, oh, well, I teach at high school. She goes, what do you teach? And I'm like, math. She goes, do you really? Okay, let me ask you this. So, which happens to me actually quite often. You'd be surprised at the questions that people like, oh, wait, you do? So I've got this boat that I need, or one person, I've got building this table, or I'm putting a weather vane on my house. All of those are true stories. And I'll go home, figure it out, I'll let you know, okay? So anyway, this was her problem. She's like, do you have a piece of paper? And we went and got a flyer from the, desk or something. And she goes, my husband and I, inherited or bought some big piece of land that had maybe a lot of timber on it, which timber's big money. I don't know if y'all know that. I don't know much about timber, but anyway, they had like the dimensions of the land, they even had the sides. But I've forgotten why, but she needed to know the area of it. And she knew all 3 dimensions. I don't know what they were, but I was going to throw some, I don't know, maybe it was 11 acres and 13 acres, and I've got to make sure that any 2 sides add up. Okay, I think that's a viable triangle. Anyway, she's like, so my husband and I need to know the area of it, maybe the square footage for tax purposes or to get somebody to come out there and do something on their land. I don't remember why they needed to know it, but they needed the area. And she goes, we have college degrees. Like, you know, she didn't say this, but she probably thinking, we make way more money than you do, but we don't know how to find the area, and we feel like idiots. So we're going to call some company of surveyors will come out for hundreds of dollars and tell us what the area is. She goes, but we know all 3 sides. And they're like, we know 1/2 base on height, we remember that. But he goes, what are we supposed to do? Like, is one of us supposed to put a tape measure on our waist and trek through the land, trying to go at a 90-degree angle to find the height? Do you see her problem? Like, they didn't know how to find the height. Like, what if there's a lake? Then she and her husband are like, you know, one of them's holding the tape measure, and one of them, wait, you're not quite straight, you know, and they're like trying to tramp through. She knew that was ridiculous. You see their dilemma? This is too big for them to find the height. And how unfortunate if they got off course somewhere and they ended up over here and said the wrong thing, then they wouldn't know the area. So I said, there's other formula for every triangle. She was so mad at her teachers. She's like, why don't I know this? So anyway, I found it for him free of charge in 13 seconds. But I should have charged her. I'm like, so what's the going rate? And, you know, anyway. So here they are. You'll write them on your memo page in a second. One of them I'll derive for you. Another one I probably won't right now, but I think it's in your book, so we can move on. One of them's really fast. All right, let's look at this. So here's their land, okay? And when you do purchase land, they do give you all of the angles and the sides. Like they got to give you that. You've got to know where your property lines lie, okay? And so if this is A, B, and C, opposite A, we always do this. You are used to that from geometry, okay? So if we drop a height down to use our pitiful little formula, okay, which you realize now on a grand scale that's ridiculous, right? I couldn't tell her to go get a protractor and a compass and construct a 90-degree angle and find the height and then get a ruler and measure it. That was not going to happen here, like what we do in geometry, okay? So now that you have trig, or even back in geometry, you could learn this one with SOHCAHTOA. So I know the sine of A is H over B. And so H is B sine A. Okay? Here's my pitiful little formula, 1/2 base times height. And this triangle, what is my base? C. And this triangle, my base is C. And what is my height? B sine A. Okay? So what if I'd done my triangle this way? B, A, C. Then this is A, B, C. What's my height? I really could have gone either way with it. Let's go over here. I'm sorry, forget this triangle for a minute. Girls, really, I'm serious, okay? I was joking a little while ago, but I'm not anymore. All right, I could have also found the height here. I'm going to go sine of B is H over A. So this height is A sine B. So if I go 1/2 base times height, what's the base? C. And the height? A sine B. So this is 1/2 AC sine B. This one was 1/2 BC sine A. So it's like what Isabella said. You have 2 sides and the angle between them. One thing I don't think I picked up from geometry, which I probably should have, is that the angle between 2 sides is always the different letter. Sorry, you may be like really worried about me that I didn't ever notice that, but I just really didn't like geometry for focusing at all, but anyway, didn't like my teacher, didn't like anything about it. So I had to learn a lot about it in pre-cal and calculus. But anyway, do y'all know that? So angle C, if you didn't know that, it's real important to what we're going to be learning today. Do you see that C is always between A and B? So what really you were saying from your ACT prep is I can do 1/2 BC sine A, or I can do AC sine B, or what's another alternative? If we keep doing this, I'm going to eventually end up with one where I could go 1/2 AB sine what? C. Remember the hinge theorem, at least the word, okay? Do you see how these two things, B and C, are hinged together? Okay? So if you have B and C, and you know angle A, everything is set in stone. There's only one triangle that can be formed with that. That's real important later today, okay? Like if I can't bend that down, if I know how they're hinged together, I've got side, angle, side. Sound familiar?
Yeah.
All right. So anyway, on our memo page in just a minute, we're going to write 1/2 AB sine C, because you're smart enough to realize you can rearrange that. If you want to write down all three scenarios, you can. But anyway, you could really forget the first one and go through your life in a better fashion, and especially the rest of your math. You could just forget, I know you won't forget the first one. But do y'all see if you do 1/2 AB sine C? That is trying to tell you could also do BC sine A or AC sine what? B. Okay? So that just means you need two sides and the angle between them. You need the hinge. You need side, angle, side. All right, then the other one is Heron, or sometimes people call it Hero's formula. It's usually referred to them, I think the man's name is actually Heron, but maybe also like, if my name was that, I'd shorten it to Hero also. But anyway, it's like this. If you know all three sides, A, B, C, okay? What Heron found is you could add up all the sides and divide by 2. And he called that S for semi-perimeter. In case you're looking at the formula one day and go, I don't know what S is, okay?
Miss Arkin taught us.
Good, so you've seen it.
Yeah.
But we revisit it again in pre-cal because you forget it, right?
Yeah.
Okay? So you've had Heron's formula.
Yeah, it's like with the square root.
With the big square root. So it really introduces a fourth side or a fourth number. It's the semi-perimeter. So you say S times S minus A times S minus B times S minus C. But girls, if it goes on your memo page, what should happen? You should now, this whole page, whatever math you're going to take from now on, you need to know this page, okay? So carry it with you. Square root of S times S minus A times S minus B times S minus C. So Chloe, that's awesome that you remembered that. Okay, these two, okay, do not care if your triangle is the right triangle or not. They don't care. So do you see how you could go through your whole life and just use these two? If I know one of the angles, I can use this one. If I know all three sides, which is what I did with that woman that day that I was chaperoning that trip. I knew all three sides. So I could do that one and tell her the area. On a quiz, when I say area of a triangle, you could give me any that you want, but don't give me 1/2 base times height. I might count off twice. Okay? Give me one of the other two. Try for yourself to alternate back and forth so that you know them both forever. Okay? All right, now let's look at what Bella brought up, because that is a good thing to know. I wouldn't even really put it on your memo page, but you could because it is important. I want my calculus students to know it. These are area of a triangle. Does everybody have them on their memo page now? Let me pause while you get them on your memo page. Well, we're almost through. Kind of get them on there in a hurry because I'm going to move on.
just need to have each part like present once, kind of like each letter.
Right. Yeah. You need two. What that means to decipher it, translate it, is you need two sides and the angle between them. You need side, angle, side. Okay. You can go in and add this also. Calculus goes a lot smoother when you're working with figures. They give you a lot of equilateral triangles, and instead of having to stop and figure out the area, you could use what Bella said. Square root of 3 over 4 side squared, we all accept that without you telling us how you derived it. We're going to derive it ourselves in a minute. So I never put that on quizzes before, but if I did, hopefully you'll know it. I'll warn you if I'm going to start putting that on quizzes. Okay? I feel like in the next, we don't have a quiz next class homework. I'm just going to take a quiz break maybe for myself, but then the next, these area of triangle formulas I feel like could come up on the quiz next Tuesday. See?
Is that the only thing in the blue box?
Only thing in the box. Good question. That's a mighty big box. I had to keep going for equilateral triangle. Okay, so I could do it with this one or this one. Actually, I could do it with the pitiful little 1/2 base times height. I'm being always a bit facetious and sarcastic, even though I'm not a sarcastic, facetious person. But in class, I risked that to really make a point. Obviously, 1/2 base times height isn't horrible, but in comparison to the other two, it is kind of pitiful, because it demands a right triangle or some work to find the height that sometimes is ludicrous work to do. All right, I could prove what Bella brought up to us with either one of the last two, or probably even the first one, but in interest of time, I'm just going to prove it with this one. So if all the sides, I put 7s, but I thought, what if we just don't know what the sides are? They're all the same, so those are S's, okay? So if I go 1/2 A, B, sine C. What's the hinge there if it's equilateral? 60. So I get 1/2 side squared. Do y'all see what Bella's saying? If it's equilateral, won't you have an A the same size as B? It'd be A squared or B squared, whatever. And the sine of 60 is root 3 over 2. So do y'all see that?
Yeah.
Okay. But it's great to go straight to it. Bella, I think I wasn't told that in high school, so when I was in calculus, the 4 or 5 times I'd encountered equilateral triangles, I think I went all the way back to square one to find it. You're welcome to please just use that, square root of 3 over 4 side squared. They're great for standardized tests also, okay? All right, now moving on. Now we're going to get into something like this, which is really why, another reason I have triangles up here. Okay, there's something, like what's going to happen if I don't have a right triangle and I need to solve everything? Like if this is 10 and this is 11 and this is 8. I'm going to switch something because that's certainly not drawn to scale. Okay. Another thing that I memorized in geometry that I didn't understand was that any two sides of the triangle had to add up to more than the third side. And until pre-cal, I didn't know why. I'm just like, because my teacher told me so. That was my mode of learning until pre-cal, and Miss White wouldn't allow that. She made us think, which was awesome. It was a little bit hard at first, but it was awesome. You remember that first class you encountered that you had to process material instead of just, I hate the word regurgitate, instead of just give it back, maybe imbibe or whatever. All right, so anyway, why is that true? Can anybody tell me why that's true? Don't say because your teacher told you so. Why do any two sides have to be more than the third side? Rebecca?
If you had like two sticks and you wanted to make them like
Very
connected
good.
with the third stick, if the two sticks like aren't equal to the size of the third stick, they're just gonna lay flat.
They don't make a teepee, they just fall flat down. So if this is 10,
Yeah, I remember the image. Yeah.
Yeah.
good.
They'll miss each other.
They'll miss each other. Do you see if those don't add up to more than 10? In fact, what if one's 4 and one's 6?
No.
As I start to bend them, they'll fall completely flat. They have to be a little bit more than the third side to make a teepee. Okay? All right, so what, girls? Watch for that. Shh. Watch for that. Some of this work that I'm about to show you, like last night's work, will be a lot of algebra, okay? And some trig. So don't fall for this. Like say on problem number 8, you see them say,
Not today.
okay?
No, it's not today. 18.
Okay, anyway. You'll catch yourself working a problem sometimes that you'll go, oh, you look in the back and realize there was no solution, or you'll get to no solution and go, did I do this right? You look in the back and go, I did that right. And then you get to class and maybe you realize your friend didn't even do any work. If you look at their homework, they just wrote no solution. I mean, like, if I started to ask you about all the stuff about this triangle, that's not even a triangle, is it?
No.
Please be aware from the, you know how I like you to be aware of the domain on the front end of a problem? Always be aware of the big picture as you go into greater mathematics, okay? So that problem is, that I would just write no triangle. That doesn't even make a triangle, like Rebecca told us, okay? So here are some visualizations of things that are going to happen to us. You can see these on our website under topics. Oh, and I told you why we're doing this. Okay, so what's going to happen is if I have 8, 10, and 11. First of all, is this viable? All right, are 8 and 10 more than 11? Or 10 and 11 more than 8? And 11 and 8 are more than 10. So this is a triangle. Granted, a poorly drawn one, but it's a triangle. It's not a right triangle. And so all of the right angle trigonometry that you have on your memo page just flies out the window. I don't have a SOHCAHTOA here. Do I have an opposite, adjacent, and hypotenuse? I don't have it, okay? So I'm going to drop an altitude with a triangle. Oh, so I'm sorry, I haven't told you what's happening. If I give you all 3 sides, I'm going to want you to then give me all 3 angles. Somebody's got to be able to do it, an engineer that gives people their dimensions on their land. Okay, how do you think people know all those things that are printed on the Vineyard Vines sweatshirts, you know, where they're degrees, minutes, and seconds, okay? Somebody's got to know how to find all these angles. Right now, we can't. You know how to use inverse sine and inverse cosine and all that stuff to find angles, but I can't. I don't have a SOHCAHTOA, okay? So we'll make this happen with a height. So this is what we're going to do with just some oblique triangle.
Could you use the like sine a? Wait, what's that like proportion?
That's what we're going to, yes.
Oh.
Okay, so this is A, B, and C. Sine of A, we go back to right angle trigonometry, is height over C. Sine C is the height over A. If I make 2 right triangles out of this. What would you do next? I also want to give you a window second semester and how people even derive formulas. A lot of times they just keep walking forward to go, I'm really sick of doing this the long way, so let's find something shorter. What would you do next? I'm just sort of moving around my triangle doing SOHCAHTOA right now. What would you do, Zaina?
Did you find the height?
I'd solve for H just because I kind of can't help myself. I just feel like multiplying by C, okay? So I'm going to say that C sine A is the height, and as long as Zaina's going to do that, then Zaina's probably going to drop down here and go A sine C. Oh, well then what would you do? They're equal to each other, Elena, right? So it's starting to evolve, and so I have C sine A equals A sine C. Okay, and we could actually give you that as a formula. Okay, we're not going to, but we could actually say C sine A equals A sine C. It also works with B and all that stuff. Somebody to make it a little more user friendly, don't know who it was, divided both sides by AC, which is legal in algebra. Here my C's cancel, and I have what I heard some of you saying, sine A over A and sine C over C. I didn't really actually completely hear what you were saying. You may have learned it this way. When you said the ratios, Nicole,
Yeah, that's what I think. That's no. Yeah, we learned it the way you just.
it also, you can see it in websites and books. If it's a proportion, does it matter which way you write it?
No.
So if you go home and do your homework with that proportion, and I go home and do my homework with this proportion, we're both going to have the same answers. I think I tend to do this one, okay? All right, so in next class, we'll write it on our memo page. We're not going to do it right now. But what we're going to do here is this. So this is what you'll be doing on your homework. So pay close attention because this can get really tricky. Please first look and see if it could even be a triangle, okay? Some of your answers will be no triangle, okay? Oh, by the way, I've drawn the triangle. What happens if I just go 8, 10, 11? By the way, there may be more than one triangle I can draw with 8, 10, and 11. You should have questioned me on that. If I actually give you sticks, like someone mentioned, if I give you sticks of size 8, 10, and 11, and I pass out 20 of them, set, yeah, I'd walk around and you all have the same triangle. If I give you all three sides, there's only one way to put this together. Even if yours is turned different, I could turn it and it would be the same angles and sides. But if I give you two sides and you're looking for the third side, there's all sorts of things that can happen. Here's your comfort zone. If you have all three sides, you only have one triangle, if any. Okay? There are times, though, where I give you two sides. Look at my elbows. Okay? I give you two sides, and you don't know the hinge. And so it could be hinged, and you could have a short side, or I could take my two arms, and I could go like this and have an obtuse angle and have a long side. I'll show you a better animation of that than my elbows in just a minute. All right, so here, what I would do, there's only one triangle possible. I've already checked, and there is a triangle, so I should get an answer. So let's call this A, B, and C. So I'm going to have 8 over sine A and 10 over sine B and 11 over sine C. So those are my ratios. Oh, apparently maybe I put those on the bottom. Am I going to be able to solve that? By the way, I'm sorry, don't do all three at one time. But don't I still have a problem? You can't use law of sines here. Another day I'll teach you law of cosines. So on all of your homeworks that you have, you're going to at least have one angle. Did y'all see the problem here? Okay, so I'm going to erase this. In fact, I don't even know how big that side's going to be when I make up an angle in a minute. Let's call this 32 degrees, okay? So now, this is B, this is A, and this is C. All right, so I'm going to say, you want to definitely use B. So I'm going to say B over the sine of 32. No, I'm sorry. What would you do? No, we don't know this side. We know these two sides and the angle between them. Are you still going to be stuck? So now let's move the angle again. So I can say 8 over sine 32 equals what? Maybe B, or 11 over sine C. Now can you finally find C? The reason I did that to you is this. You notice the problem here is I don't know the angle between them. I do not know how they're hinged together, so there could be more than one answer to this problem. Maybe it's a short little side, maybe it's a long side. Okay? Here's the issue that I want to say before you'll be doing the ratios in your homework. And we'll talk more about the issue next class. I'll save some more time to talk about this thing that they call the ambiguous case. But stay with me till 11:25, because you know I'll go that long. There's sometimes that two triangles can be created with this, and I'll show you an animation in just a second. But here's the problem. You're going to carefully and precisely cross multiply and divide. You see at the end, you're going to end up with a sine C equals something. And you're going to have to push arc sine on your calculator. What if you end up with sine C equals 1/2? You won't in this problem. But what if you did? What would your answer be? What would angle C be? Do you know if it's 30 or 150? You don't know. So that's how you could get two different answers. And, a lot of times you won't have a picture, okay? You'll just have the three things listed. So you don't know if it's like this or like this. Could the triangle have an obtuse angle?
Yeah.
Okay? And then it changes everything except for the two things you were given. So, let me show you this real quickly and then we'll go. There's a place on the website that has law of sines on it. And it's got a little building. Where's my building? Oh, here it is. All right, as you're packing up, look up here at this animation. But do be packing up. Now, sorry, it's loading. Do you see how there could be no triangle? Okay. But you see also it could swing back and forth and make two triangles. There's also a set place in here where there's only one triangle. I happen to know it's at 4.5 because I've done this before. It doesn't have to be a right triangle, by the way, but do you see it could be too short and be no solution with the given statements? Do y'all see 4 and 9 and 30?
Yeah.
That would be a no triangle. That's two triangles. Sometimes you could get one. You can't get more than two, okay? Wait until I say update it on the homework before you do it. It's already been posted, but I may tweak it a bit based on how far we got. No memo quiz, just bookwork.